So when we talk about the sciences and we talk about how we go about understanding the world around us, one of the key sort of procedures and methods utilized to understand the world around us and to begin to explain what we see in the world around us is the scientific method. So science is based on observations. Observations can be either collected data that I like to call quantitative observations or descriptions of a phenomena, which we call qualitative. Now, what's important to note when you think about an observation is that observations do not attempt to explain the collected data or phenomena. An example of collecting what I would view as qualitative observations would be, for example, if we look at a balloon and what happens to the balloon if we take a balloon at room temperature and then we place it on ice. So we can list some observations and we can collect both quantitative and qualitative observations. So for example, we see that if we compare the room temperature balloon to the balloon that's around 0 degrees Celsius, we see that at lower temperatures, this balloon is clearly smaller. Now, that's a qualitative observation. We can collect quantitative data and we can record the volume as some value with a number and a unit. So you can record the volume in milliliters, certainly. So observing and qualitatively describing the size of the balloon, that's a qualitative observation. The balloon is small. We can collect quantitative data by measuring the volume. In either cases, we see that as we decrease the temperature, the volume or the space occupied by the gas in our balloon decreases. Okay, so we've observed something in the world around us and we've collected some observations. Now, once we start to collect a range of observations for a set of phenomena, so let's say we look at the volume of gases at different temperatures. So let's suppose in the next experiment, we were to look at what happens if we place the balloon in boiling water. So as we begin to collect observations for a given set of phenomena, we can begin to develop what's known as a scientific law. Now, scientific laws provide a summary of past observations and provide a prediction of future observations for a system. So scientific laws summarize the observations collected and have predictive power for future observations. An example of this applied to our balloon example is Charles' law, which states quite simply, as the temperature of a gas decreases, the volume of a gas decreases. Now, we haven't really explained why this is happening. What we're doing is we're summarizing all of the observations that we've collected. And from this scientific law, we can predict what happens if we change the temperature of a gas, what will happen to its volume. So a scientific law has a very large amount of predictive power. Now, if we really want to get at fundamentally understanding what's happening in the world around us, we don't just want to be able to summarize our observations. We want to be able to explain why these observations are observed. And this is where we start to get into this idea of a hypothesis. So from observations, scientists will formulate what's known as a hypothesis, which is an explanation for the collected observations. A hypothesis provides predictive power and generally should be testable via experimentation. Now, how exactly do we go about testing a hypothesis? So to do that, we design experiments. And experiments are carefully designed procedures aimed to refute aspects of a hypothesis or provide supporting evidence for that hypothesis. Now, a hypothesis can be revised to account for collected data, or it is discarded if it cannot be reconciled with the collected observations. And through this process of proposing a hypothesis and then revising your hypothesis, you can begin to start to explain the observations that you observe and that you've collected. So after this long process of proposing a hypothesis, performing experiments in an attempt to refute or support the hypothesis, eventually a hypothesis becomes a well-supported hypothesis that serves as the basis for a theory. So a well-supported hypothesis becomes the basis for what's known as a theory. And a theory is a model for the way nature is that tries to explain what nature does and why. It serves to explain natural laws and observations. So for example, when we've talked about Charles' law, where the volume of a gas, like our balloon, decreases when the temperature decreases, that is a scientific law. Charles' law can be explained and rationalized using kinetic molecular theory, which explains observations of gas behavior by describing gases as a collection of moving particles. So for example, when we look at our balloon, kinetic molecular theory says we can describe the gas inside the balloon as a collection of moving particles. And based on the temperature, these particles will move more or less rapidly. And so at low temperatures, your volume contracts because there's a smaller amount of molecular motion pushing out against the walls of your balloon. The gas in your balloon is the particles are moving less rapidly, they're colliding with the walls less frequently and with less force, so the balloon contracts. So a law serves to summarize your observations and has predictive power, while a theory attempts to explain our observations and help us understand the world around us in a way where we can begin to predict what will happen when we change. So we can use kinetic molecular theory to predict what would happen if we change the temperature, what would happen if we change the volume of a gas. So a theory is wonderfully useful to help explain our natural laws and observation while having an adequate amount of predictive power for future observations.